Welcome to section 2.4, set operations and Venn diagrams with three sets. Objective 1, perform set operations with three sets. So when using set operations involving three sets, perform the operations within parentheses first. For example, we're going to let the universal set be 1, 2, 3, 4, 5, 6, 7. Set A 1, 3, 5, 7. B 1, 2, 3, and set C 2, 3, 4, 5, 6. If we're asked to find A union the quantity B intersect C, we will first begin with the parentheses. B intersects C. So we want to find the intersection between set B and C. So we'd find that first, and that would be the set 2, 3. Then we would apply set A union and then set of the intersection, which was 2, 3. Now we will find the union between these two sets, giving us the set 1, 2, 3, 5, and 7. Okay, so whenever you're working with three sets, you always want to start with what is in the parentheses first and then work your way out. So let's do a couple. All right, number 1, we are given the universal set A, B, and C, and we're asked to find the following. So we're first going to find what is in the parentheses first. So the intersection between set B and C. And that is going to be the letters B and F. Okay. Next, we want to find the union between this set and set A. Now, set A is the letters A, B, C, and D. So A union B intersect C would be the elements A, B, C, D, and F. Awesome. The next one, we have to find the intersection between the union of A and B and the union of A and C. So let's first find the union of A and B. So everything in A and everything in B. That would be the letters A, B, C, D, and F. Then we'll find the union between A and C, which would be the letters A, B, C, D, and F. So the intersection between the union of A and B and A and C would be the elements A, B, C, D, and F. Awesome. All right. It's a little bit more trickier. That's okay. We got this. We first are going to start off with what's in the parentheses. So B union the complement of C. Okay. Now inside this parentheses, we have a set that isn't given to us, and that is the complement of C. So now we are going to find the complement of C first. Okay. So the complement of C is going to be the elements A, D, and E, because these are the elements that are in the universal set but are not in set C. Now we can take this with set B, which is A, B, D, and F and find the union between both of these sets, which would be the elements A, B, D, E, and F. Okay. So now we'll take this union and find the intersection it has with set A. And set A is the elements A, B, C, and D. So A intersect with the union of B and the complement of C is going to be the elements A, B, and D, because that is all that these two sets have in common. So, objective 2. We need to use Venn diagrams with 3 sets. So to construct a Venn diagram illustrating the elements in A, B, C, those are our 3 sets, and the universal set, we're going to start by placing the elements in the innermost region and then work outward, because the 4 inner regions represent various interactions. So we'll need to find the intersection of A and B, A and C, B and C, and then the intersection between A, B, and C. And then use these intersections and the given sets to place the various elements into regions. Now, before we start constructing Venn diagrams, let's first visualize a Venn diagram with 3 sets and answer some questions. So we need to use this Venn diagram to determine the following sets. Now, in previous sections, we've looked at Venn diagrams with just 2 sets. But in a 3-set Venn diagram, we have a lot more regions. Okay? So we have 2 questions here we need to answer. What is the intersection between set B and set C? So we know the circles represent the sets. So we're going to look at the circle of set B and we're going to look at the circle of set C. And we want the intersection just between set C and B. Now this set would contain the elements 5, 7, and 9. This would be in region 4, sorry, that's 5. 5 and 6, numeral numbers. 5 and 6. Okay, 5, 7, and 9. That is where the set B and C overlap. Now we're going to look for the complement of C. So we want to know all of the elements that are in the universal set, but are not in set C. So we'll identify the circle for set C. So we want every single number that's not contained in C. And that would be the numbers 11, 3, 12, 1, 2, 10, and 4. So this would be in regions 1, 2, 3, and 7. Right? Wait. 5, 6, 7, 8. That's 8. That's not 7. 8. Region 8, which is where 4 is. Okay? So now that we've dabbled a little bit into some problems surrounding the Venn diagram with 3 sets, let's create one. So here we're asked to construct a Venn diagram in illustrating the following sets. So we know we are going to create a Venn diagram. So let's draw an image here real quick. And I'm going to have my 3 circles that overlap. Okay. I'm going to label them. So this is set A, B, C, and my universal set. Then I'm going to name my regions 1, 2, 3, 4, 5, 6, 7, 8. Okay. And so now I'm going to answer my question, which is to construct this Venn diagram with the following sets. So I first need to find 4 intersections. So A and C, well, first A and B, sorry. A and B, then A and C, and then B and C, and then A, B, and C. So I need to find the elements that go into all of these. This is where all the intersections between the subsets happen. Okay. So A union B. So what does A and B have in common? They have the number 10. A and C, what do they have in common? They have 3 and 10. B and C, what do they have in common? 4, 9, and 10. And then A, B, and C, what do all 3 sets have in common? 10. Okay. So now that I've identified the intersection parts of my Venn diagram, I can now start placing values in my Venn diagram. So the first one that I'm going to start at the innermost, which is going to be the center, and that's going to be region number 5. Okay, that's where my sets A, B, and C all intersect each other, and that would be the number 10. Okay, so I'm first going to start with region number 5. That's what you start with first. Okay, next I'm going to start with my other intersection parts. So this would be A union B, or sorry, not union, there's no union. A intersect B, which is also 10. Okay, so A and B also share 10. And that's the only number that they share, which means that there is nothing in region number 2. There's nothing here. It's the empty set. Okay, the empty set. All right. Okay, third step is going to be A intersect C. Let me put some regions here. So this would be region 2 and 5. So A and C. So that would be region 4 and 5. So A and C have 3 and 10 in common. So 10 is already there. So 3 would go here. And for step 4, we do the intersect of B and C, which would be region 5 and 6. B and C have the numbers 4, 9, and 10. 10 is already there, so I would add 4 and 9. Step 5, we would then look at A, set A. So in set A, we have the numbers 1, 3, 6, and 10. That's what's given to us. Okay. So in set A, we already have placed 3 and 10. So the only elements that remain are 1 and 6. Okay. Then for step number 6, we'll look at set B. For set B, we have the numbers 4, 7, 9, and 10. For set B, we already have 10, 4, and 9. So the only number missing is 7. Step number 7 would be set C. For set C, we have the numbers 3, 4, 5, 8, 9, and 10. In set C, we already have 3, 10, 4, and 9. So what's remaining would be 5 and 8. And then for step number 8 is the universal set. Okay. So all the numbers that aren't already within the subsets A, B, and C. So that would be the number 2. Okay. So this would be region 1 that we did, and then region 3, region 7, and then region 8. Okay, so we do it in that order. Okay. All right, the third objective, use Venn diagrams to prove equality of sets. So if two specific sets represent the same regions of a general Venn diagram, then this deductively proves that the two sets are equal. So if the complement of A intersect B equals the complement of A union the complement of B, then we would say they are equal sets. If the complement of A union B equals the complement of A intersect the complement of B, then we would say they are equal sets. So let's use the Venn diagram to solve this exercise, or in other words, prove De Morgan's laws that we just stated. So we have our Venn diagram here. And our first question is asking us which region represents the complement of the union of A and B. So we want the complement of the union of A and B. Well, the union of A and B would be represented by regions 1, 2, and 3. Therefore, the complement of those 3 regions would be region number 4. Okay. Now, which region represents the complement of A intersecting with the complement of B? Well, the complement of A is going to be represented by region 3 and region 4. The complement of B is going to be represented by region 1 and region 4. So the intersect between both of those would be region 4. So let me flesh this out a little bit for you. So A, B was region 1, 2, and 3. So the complement of this would be region 4. You only have 4 regions. The next one, the complement of A, is region 3 and region 4. The complement of B is region 1 and region 4. So the intersection between these two would be region 4. Okay. So based on the parts A and B, what can we conclude? We can conclude that the complement of the union of A and B equals the complement of A intersect with the complement of B, because they both represent region number 4. All right, let's do another one. All right, we're going to use this Venn diagram to solve this exercise. Note that our Venn diagram here has 3 sets. In the previous one, it was 2 sets. So which regions represent A intersect with the union of B and C? So let's flush this out so you can have this on your notes. So B union C would be the regions 2, 3, 6, 5, 7, and 4. I forgot 4. Okay, so B and C. Now A would be the regions 1, 2, 4, and 5. So we now want the intersection between the two. So what do they have in common? So that would be 2, 4, and 5. Okay, let's do the next one. Which regions represent the union between the intersection of A and B and the intersection of A and C? Okay. Well, the intersection of A and B is going to be the regions 2 and 5. The intersections between A and C is going to be 4 and 5. So the union between both of these will be the regions 2, 4, and 5. So what can we conclude? Well, A intersect with the union of B and C is equal to the union of the intersection of A and B and A and C, because they both represent regions 2, 4, and 5. Awesome. Well, that concludes section 2.4.